Hi, my name is Fábio de Souza. I'm a master's student at University of Campinas and a research developer at NeuroMind. I'm going to talk about our work, Pre-trained Portuguese BERT models. I'll begin by introducing the background and motivations of this work that will lead us to the objectives. Then I'll talk about the methodology involved in training our models, with an overview of how BERT models are trained and the data that we use. And lastly, I'll show the results and the conclusions. Recent works on deep learning have made great progress on many natural language processing tasks by using transfer learning, in which a model is first trained using language modeling objectives and then fine-tuned to downstream tasks, such as question answering and language modeling inference. Examples of such models are ULM-FIT, ELMO, OpenAI GPT, BERT, T5, and the list goes on. This transfer learning approach works well because in the pre-training stage, the model learns a language representation that is useful to other NLP tasks. And it not only helps to improve the performance on various tasks, but can also reduce the amount of annotated data required to reach a determined performance level. So, considering that less resourced languages, such as Portuguese, usually have small annotated datasets, pre-trained language models can be valuable tools. These models are interesting because fine-tuning a pre-trained language model is cheap and doesn't require many architecture modifications to apply them to different tasks. However, pre-trained models are often available only for English, Chinese, or multilingual models that don't perform as well. And training these models from scratch require vast amounts of computational time and specialized hardware, such as multiple GPUs or TPUs. The good news is that pre-training has to be done only once. So, the objective of this work is to train BERT models for Brazilian Portuguese. BERT stands for Bidirectional Encoder Representation from Transformers. It was published in late 2018, and it made a huge impact on the community. So, how is BERT trained, and what do we need to train a Portuguese version? This image shows an overview of the training stage using the masked language modeling task. BERT is treated as a black box, and it receives a sentence at its inputs, and it outputs representations for each word in the context of the sentence. In the pre-training stage, 15% of the tokens are replaced by a special mask token, and the output of the masked word is used to predict the original word. So it's a classification task on the entire vocabulary. To train a Portuguese BERT, we need then a Portuguese vocabulary and a lot of data to feed the model. So the first step is to generate a Portuguese word piece vocabulary with 30,000 subword units. It's trained on 200,000 Wikipedia articles. At the bottom, we have a tokenization example. So for an input, gerar vocabulário em português, the tokenization keeps whole words if they are in the vocabulary, and if not, it breaks them into non-pieces, such as the word vocabulário that is broken into voca and bulário. The second step is to gather unlabeled data, preferably with high diversity and good quality. For that, we use BR Walk Corpus, a web crawl of Brazilian web pages that meets these requirements and has 2.6 billion tokens. As a comparison, English BERT was trained on 3.3 billion tokens. With vocabulary and data in hand, we then train BERT models on two size variants. First, we train a BERT base, a smaller variant, and this training takes 4 days on Cloud TPU. Then we train BERT large, which takes 7 days on Cloud TPU. After the models are trained, we then evaluate their quality on named entity recognition task. To do that, we pick a pre-trained BERT in yellow and add a classifier for the task on top of it, and then we fine-tune the complete model using labeled data. For this experiment, we use the Harem datasets for train and test. They have 10 named entity classes, such as person, organization, location, time, etc. Our Portuguese BERT models outperform the previous state-of-the-art by 4 points in F1 score, and also a multilingual BERT by a similar amount. So to conclude, this good result on NER indicates that Portuguese BERT can provide useful language representation for downstream tasks. By making our models available, we hope others will be able to apply BERT on their problems and increase the performance of many other tasks in Portuguese. Our models are available on our GitHub repository. Thank you.